Hi everybody, it's great to be here with you today. My name's Matthew Collier and I'm here to talk to you about maximising your potential in the lab. So I got started in this field as a high throughput scientist with a role at AstraZeneca in the high throughput screening department. And I got that role in 2012. So I've been working in the lab automation space for the past 13 years. In that role, I had a natural aptitude towards the automation and the robotics. So I built upward from there, working my way to becoming an automation scientist in the high throughput screening department. My role as an automation scientist was designing and troubleshooting automation workflow solutions in the lab. So from there, I got a role at Biosero, where I've been working as an applications consulting scientist for the past year, bringing automated solutions to laboratories around the world. And I'm telling you all this history about me because I want you to know that first and foremost, I'm a scientist. I'm someone who, like many of you, has been in the trenches working on systems in the lab. And I'm now also trying to make automation accessible for as many labs as possible by working on the provider side. So with all that said, I wanted to share with you today what we're seeing on the very edge of the industry right now. It's the type of work that Biosero is working to enable currently, and it's where I see the next wave in automation taking place. I'm hoping that by sharing this information with you today, it helps to show you the reality of what's possible in labs right now and to help all of us in the field really raise the bar for what's possible and get thinking about what we can achieve in our labs. The integrated system you've been watching on this video on the screen right now is a system Biosero built last year, and it's living proof of this new paradigm that I'm about to talk about in this presentation. So to get started, I want to go to the very basics and build up a story that centered around a common theme that I feel we're seeing around a lot of labs in the industry at the minute. But this story begins with a lab that has some scientists, and we'll say there's 10 people working in our lab. Historically, this lab has been doing NGS work, and it's work similar to what I was doing and helping to enable at the start of my career. To help them increase throughput, they brought in a few liquid handlers and some robots, and they, like all of us, believe that when automation is really working at its best, it's empowering scientists to be more creative, and it gets them out of doing the manual tasks such as hand pipetting and enables them to do things that matter, that actually make use of their brain and their expertise. This lab has gone through a number of changes over the years, changes from the pressure on the business, pressure that's come from management, and that's kind of translated to a cash pressure in the lab. So when they lost a few people from natural turnover, those roles weren't backfilled. So the team has gone down to only a team of 7. But the number of samples they're being asked to process is being increasing more than ever, with them being expected to keep the quality of those samples high. And there's an ever-ready need for a new market-ready discovery that's still extremely urgent. So this lab is being driven under this common theme that I mentioned on the previous slide. They're being asked to do more, and they're being asked to do it with less. So from what I've seen from here, it's actually a natural point to get deeper into lab automation. The team go to their finance team and convince them to invest in the automation in the lab and add more more automation to their laboratory. So they now have several automated work cells, each running separate parts of the process. In one work cell, they're doing automated storage. The next work cell has some doing the nucleic acid extraction, with the liquid handling sections, sealing, peeling, pipetting, You've got a work cell that's centered around library prep, and so on. They're essentially automating as much as the physical process as they can think of. And that automation is helping them keep quality high, but it's also making the samples more accurate and precise as they tackle the larger sample volume. Plus, now they've unlocked more hours of productivity because the automation can run overnight, it can run on a weekend, it can run on a set schedule. If they're using GBG Scheduler with our GBG Orchestrator software, they can monitor their systems from their phone instead of the next room, and they can have the workflow spanning all the hardware in the lab, allowing them to tie various workflows together. All of these features are helping them build up that walkaway time and giving them that time back that I mentioned previously. So at this point, the team feels like they're doing all they can to find efficiency and boost production. But their management team comes back to them and says, you need to do even more with what you've been given. And this is the crucial point. It's the point we've been working with so many labs, and it's the point where you've done everything within your lab to speed things up, and you're still looking for more room to maximize. They've done so much work to automate the physical side of the work and even some of the logical aspects. And it's a case of where do they go from here? And this is the point that I really want to talk with you about specifically today. And that's the next horizon of automation, which is managing the data side of the work. So what that means ultimately is that we need a layer in the lab that's pulling and pushing the data from the hardware running the system. In the case of our story here, that layer is GBG Orchestrator, which is an interface for all of the equipment, but it's also able to connect up and out to other parts of the lab. So now we can get the IT team involved and connect that data and allow it to flow into software such as Power BI and Tableau for better reporting capability. More importantly, the data is also flowing into software that can analyze the results of a run and is then able to flow into new AI-powered tools that are looking for very specific things, goals set by the scientists in the lab. And this is the point that's truly the next step. It's taking the output from that whole cycle and actually queuing up the next run to analyze the next set of data, taking into account everything that's just been learned. So the output from the whole process can then be fed back into GBG Orchestrator, which translates that information into run data, kicking off the process again from the very beginning. So what that means is we've now been able to optimize and automate the truly physical side of executing the research. We've also automated the logical flow of activity and automated the movement of data itself through the lab. So where you originally had a small team of scientists tasked with a lot of minute and tedious tasks through the day that still had to be innovative under pressure, that small team is now focused laser sharp on their objectives, on designing the best experiments for the purpose, and on taking advantage of all the modern advances in technology available to them in the lab and putting a rocket behind the work that they're doing. There's now room for IT specialists to connect to this scientific ecosystem and make use of their specialities, and for developers to get involved in ways we used to think were really hard or close to impossible because elements in the lab were so far apart and disconnected. The way this comes together is actually relatively simple. Here's an example of how we connect the existing work cells via an informatics adapter. In this case, we'll use Tissue Mosaic as our example. So, in this example, we have a job that currently resides in Tissue Mosaic. Instead of having to manually prepare that job to execute on the work cells and making sure that the order is in the right place, at the right time, and in the right format, Mosaic and GBG Orchestrator are now connected. So GBG Orchestrator can accept that job from Mosaic and translate the order into identities that the GBG system can understand. GBG Orchestrator connects to GBG Scheduler, which is running on the individual work cells and ensures that the job is completed as expected. Once GBG Scheduler signals that the job is complete, that job status and all that data collected along the way are passed back to GBG Orchestrator, which takes care of finally passing this information back to Mosaic. So not only is the actual execution of the job automated, but the passing of data between systems and the ability to queue the work order is also now automated. All of this reducing the burden on the scientists to take care of all that connective tissue. Biosero made its name building drivers for devices to connect into GBG Scheduler, but what's also important to know is that we're building informatics adapters too that connect outwards to digital solutions that allow you to integrate with the IT tools your department is already using or wants to use, and with other major modern scientific software solutions like Titian, Benchling, and more. I'd also like to give an example of how this methodology works for another application area. We recently worked with a startup doing drug discovery to make these kinds of digital connections between the hardware that executes the software and their proprietary AI that helps to focus on specific molecules. This startup was able to leverage all the classic tools of automation to physically execute the work, but they were also able to gather all the data from the run to pass it outwards into additional tools. So automating the physical and digital sides of the workflow allowed them to achieve some major gains. And this is what we're seeing from these companies that report back on what happens when they work with the data that way. They truly get a boost. They're being asked to do more with less, and they're actually achieving it. In the case of the drug discovery startup I mentioned, they saw a dramatic change over previous processes. They fully automated the design, make, test, analyze cycle and were able to improve the efficiency of their work by orders of magnitude. They were able to reduce the work of 2 months down to just a few weeks for synthesis, and ultimately they were able to significantly reduce the cost of their drug discovery efforts by streamlining so much. Another major pharma company Biosero is working with also reported massive savings using the data in a similar way, ultimately increasing efficiency, allowing for parallel processing and ensuring that their scientists' time was maximized. And this is really the message I'm here to share with you today, that the next wave of automation is so different than the past, where I started in the lab messing around with a kit on the bench. But this next wave is different because it's digital. It has the opportunity to help every scientist truly accelerate the work that they're doing. Thank you very much for your time. And if you want to catch up, I'll be at the event as well as my colleagues from Biosero